1. Okay, we're working on questions 17, 18, and 19 on the ACT. So, or on your ACT packet. Now in this one, I have to solve for y. So I'm going to subtract 1. Oh, I'm sorry, that should be minus 1. My apologies. So add 1. Is that correct?
Yes.
Is that correct? Okay. So now I have 2y is less than or equal to 10. When I divide by 2, y is less than or equal to 5. So now, how do we graph it? What does the graph look like? Well, it's a line,
It'll have 1,
0,
5.
5, and negative 5. Now, this is less than or equal to, does it get a closed circle or open circle?
Close.
Closed. Okay, so it gets a closed circle. Y is less than, where are my numbers getting smaller? To the left or to the right?
Left.
To the left, okay? And so I would graph it like that, okay? Any questions? All right, then this one. I want to know what the value of the function m, where m is negative 2. So I take 2, always, 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 when you're working with negative numbers, put them in parentheses within your functions. So put negative 2 right there, plus 4, that's going to be 2, negative 8, plus 4, negative 16 plus 4, negative 12. Okay? Y'all good with that? Okay, this will be part of your test on Friday. All right? So now this one. I have AXC is 110 degrees. BXD is 90. They want to know how far is it from here to here. Well, if I know this is 90, this is 110. Okay, how far is it from 90 degrees to 110?
20 degrees.
20 degrees, and that is my answer. 20 degrees. All right. Any questions on the ACT part? 17, 18, 19. Any at all? Okay, going once, going twice. All right. Now, the next part is where I told you at the beginning of this week, we're going to start doing math that you've never done before. It's completely new, completely different. Somebody today asked me, how long will we be doing this? Okay. Uh-oh, why is it? Okay. Uh-oh, it's blurry for some reason. There we go. Okay. So, now I have 1 through 7. Okay, and we're going to be using this page right here. So everybody get to where it says segment proofs. Okay, the handout I gave you, you are going to need when you do your take-home proofs. Okay, when you do those, okay, you're going to need this along with your properties of equality sheet. Okay, to see what they look like. Because what they look like on here is what they look like, okay, on your segment proofs. All right? Y'all got it? Any questions? All right, so everybody, we should be on what page there, Dustin? 20. Okay, so we're starting on page 20. Now, I'm going to give you some of these at the beginning, just to give them to you so that you understand, okay, that's what they're looking for, all right? So, on number 1, the reasons are always given. Under reasons, line 1, it is always given. Okay? There we go. Number 2. Okay, now, if you see in the given the word midpoint, know that definition of midpoint is going to come up at least once, sometimes twice. Okay? So, when I put E in the middle of DF, so that DE equals DF, well, that is midpoint definition. Midpoint definition. Okay? Then on number 3. Okay, now I just added something in. Okay? To where now I took DE and DE, okay, and I added it, and then I took DE and EF. Okay, this is known as addition property. Now, this could also be segment addition since we're dealing with line segments, okay, but for the most part, since it's not technically adding different line segments, okay, to equal a total, then we have to use addition. Okay, now, from step 3 to step 4, what changed? Okay, this is where I need your input. What changed from step 3 to step 4? Everybody look. What changed from 3 to 4?
You combine.
I combined. What do we call combining like terms? We used a word for it.
Distribute.
No?
Simplify.
Simplify. So in number 4, it's simplify. Okay, combining like terms, simplify. Okay, on number 5. All right, now we take DE plus EF to equal DF. So we took 2 parts of a line, added them together, and got the distance of the whole line. Okay, so that's segment addition. Okay, segment addition. All right, number 6. Number 6. Okay, now, here's where I've gone. Starting back at 4. I have 2DE is equal to DE plus EF. Then I took DE plus EF and made it equal to DF. So now I can take in the last one, number 6, 2DE is equal to DF. So I went from 1 to 2 to 3. And that is transitive property. Okay? Transitive. Okay, any questions on that? All right, any questions on 1? Okay. Again, we're still on page 20. Okay, now we're looking at problem 2. All right, so this is a 4th step. All right. Again, midpoint is mentioned, so more than likely definition of midpoint is going to show up at least once or twice. All right, so number 1 is what? Given. Okay? We know that automatically. Step 2. Okay, now I want you to look at, okay, take a look at step 2. And turn back to your reference sheet and look at definition of congruence. Okay, you see it in two spots. You see it in number 1, and you see it in number 11. Okay? Now, with both of those, whether it's going from without line segments at the top to line segments, or going from line segments to without, it's still definition of congruence, correct? All right, so flip back to your page 20 and look at what takes place from number 1 to number 2. What is that? To go from number 1 to number 2. Yeah, definition of? No. Definition of congruence. Okay? Because whether you're going like in step 1 to step 2, okay? All right? Or step 2 to step 1, it's still going to be congruence. Okay, number 3. So now, I've said that KL is equal to LN, LM is equal to LN, so now I can say KL is equal to LM. What is that? Till I go from one step to another to another. 3-step process. We used it in 1. No? Transitive. Okay, everybody look up here for a second. Transitive. Okay, transitive is going to be used a lot. All right? Congruence is going to be used a lot. Whenever you see midpoint, you know midpoint's going to be one of your reasons. But then also, between congruence and transitive, all right, really, and substitution, okay? Those are probably the 3 most common ones. All right, so now, we've needed to prove that L is the midpoint. We've gotten all the way down to number 4, and we say L is the midpoint. So what do you think the reason for number 4 is?
The definition of midpoint.
Very good. Definition of midpoint. Any questions on that? Okay. All right, number 3. We have 7 steps. Okay. What is always the first one?
Given.
Given. Okay. So it is always given. Okay, now, take a look in number 2, okay? Take a look at number 2, going from step 1 to step 2. Look at what took place there. What did we call that in number 2? Congruence. Definition of congruence. Now, take a look at from 1 to 2. What would we call that? Isn't it the same thing?
Yes.
Yeah, so what would 2 be?
Definition of congruence.
Definition of congruence. Number 3. Okay, I'm dealing with, there's a couple of answers you could do for this, all right? But because it is particular in the fact that TQ plus QS equals PS, and TQ plus QU equals TU. Again, don't forget to look at the drawing that they have right here, okay? So that you're able to kind of see this. So, on number 3, since I'm given the whole line, this is segment addition. Okay, because I'm saying that if I take part of a line Add it to the other part of a line, I get the whole line. Take part of a line with the other part of a line, and I make the whole line. That's segment addition. Okay, now, pay very, very close attention. If I take TQ and QS, okay, and add those two together, I get PS. What did I do there? Compare it to number 3. What did I switch out? Instead of PQ, I used what? TQ. So what would we call that when we replace it? Substitution. Okay? So I used substitution. Okay, on number 5. QU equals QS. Oh, I'm sorry. So now, I'm taking TQ plus QS, and now I'm making it equal to TU. So what did I do there? Same thing, substitution. Okay, number 6. Now, look at what I did from 4 all the way to 6. I made an argument that TQ and QS equals PS. TQ plus QS equals TU. So because TQ and QS are the same thing, I'm now able to say PS is equal to TQ. So what would that be? What type of process? Put that away, please. Come on, pay attention. Okay? Yes, transitive. Because I'm making that leap. Okay, it's again 3-step process. Now, what we do in, okay, now everybody look at 6 and 7 and compare it to 1 and 2. Take 6 and 7 and compare it to 1 and 2. It's the same thing, so what would we call that? Definition of congruence. Reflexive, Trent, is where it's x is equal to x. That's reflexive, okay? With this one, okay, we're just changing it from equal to congruent, okay? And so that's congruence. Okay, everybody turn your page over to number 4. All right, turn your page over to number 4. And we're going to finish up with 4 and 5. Okay, 4 and 5. Okay, so number 4. All right, number 4. Okay. All right, so if I have a particular word mentioned twice in 1, what do you think the answer is for 2? Look at the statement in 1. Yeah, so definition of midpoint. Okay. Okay, definition of midpoint. Now, I want you to look back at the stuff that is given. K is the midpoint of JL, M is the midpoint of LN, and JK equals MN. So what do we see in number 3? Given. So number 3 is given. Yeah. Somebody says, why? Just because they chose to. Okay? They gave us that little bit of information. All right, so now on number 4. Okay, JK is MN and JK is KL. So now I'm saying MN is equal to KL. and LM is equal to MN. So it's not symmetric. What is the only thing that's being changed from 2 to 4?
LM and then KO. Wait.
No. LM and MN are the same. KL is the same. What do we do with JK and MN?
Y'all switched it.
Yeah, what do we call switching? Substitution. Okay? Substitution. Okay, number 5. All right, so now, if I say JK is equal to MN, MN is equal to KL,
Isn't that? Wait.
okay, so we're on number 5, right?
Yes.
Okay? So on number 5, if 4 is MN to equal to KL, LM is equal to MN, so now LM is equal to KL, that is what? Transitive. Very good, Destiny. Like I said at the very beginning of this week, and what I'll say several times more, this is a completely different type of math than what you've ever done before. All right? So it's going to take us a while to get used to it. Don't get overwhelmed. I know what your limits are. All right? But just know that we're going to continue to grow from this. But it's not going to be to a point that you don't understand. All right.
I got the next one.
Okay, what's the, okay, this is the 6th step. So what's the answer, Trent?
Symmetric.
No. So close. Look at 6 and 7 on 4, and look at 5 and 6 on 5.
Is it congruent?
Yes, congruence. Symmetric, Trent, is where they are switched. To where if M is equal to 10, this is symmetric right here, Trent. 10 is equal to M, and then the next one, M is 10. That's symmetric.
Oh.
What this is congruent. Okay, y'all been doing great. We've got one more to go. Okay? Wait, did we finish 4?
No, we stopped
We've
some
got
stuff
one.
after.
Yeah, okay. Oh, heavens, I looked down. My fault. Okay, on number 6, my fault. Trent, I was looking at the wrong part. Okay, 6 block, I'm sorry. Okay. Trent, you were absolutely right. I was looking at number 6 on number 5. My fault, old age. So, you got it right, sir. It is symmetric. Okay? Then, since it is symmetric, I'll let you take it to the end zone. Trent, what's the answer for 7?
Definition of congruent.
Very good, congruent. All right. Again, 6 block. I'm so sorry about getting lost. All right. So now let's do 5, and that'll be it for today. And then I will have your homework posted, okay, to where I have to do is listen and follow tonight. Okay, that's all I want you to do is just listen and follow. All right. Oops. Okay, on number 1, okay, we obviously know it's given. Okay, let's see if you're catching on. What is number 2?
Definition of congruence.
Very good. Congruence. Okay. Number 3. What are we doing there? Segment addition. Number 4. Y'all are doing very well so far.
Substitution.
Substitution. Okay. Number 5.
Congruence.
Not congruent.
Transitive.
Transitive. Because I went from step 3, used part of step 4 to get to 5. So when you see that, transitive. Okay. And then everyone.
Congruent.
Congruence on number 6. All right. Okay, that's on page 20 through 21, correct? Okay, numbers 1 through 5, right? Okay.